if you miss part 1, you can go check part 1 in our YouTube channel, or you can email us if you want the recording of the video. So firstly, thank you for joining this webinar. So before we go any further, I would like to show you this. Before we go to the simulation, I'm going to show you what is Ansys. Ansys is a multi-physics simulation. These are all the physics that are included in the simulation. So for today, we are using our electronics product. So electronics, Ansys Electronics include FHSS, Maxwell, SI Wave, iSpec, MotorCAD, EMA 3D cable, Q3D extractor, EMA 3D charge, and NoFX filter solution. So if you want to find out more about all these electronic products, you can go to this website here, ansys.com/product/electronics. And for today, we're going to use Ansys Maxwell for simulating the electromagnetic brake. So what is Ansys Maxwell? Ansys Maxwell is a 2D and 3D electromagnetic field solver for low frequency application. The low frequency application includes this permanent magnet, electromagnet, actuator, electric motors, transformers, wireless charging, switch, or circuit breaker. And it solves static frequency domain and time varying magnetic and electric field. Maxwell also offers some specialized design interface for electric machines and power converters. And for today, our main topic for part 2 is how we convert from a 3D design to a 2D design. So this is a very good function in Maxwell that can be used for designing a 2D product, a 2D design from a 3D design. So for using the create 2D design function here, it allows user to convert a 3D design to a 2D design. So previously, from part 1, we already create step by step on how to create the electromagnetic brakes. And now we are trying to create a 2D design of that electromagnetic brakes. And after we create it, we simulate it, and we want to find what's the difference in the result of the simulation. We want to compare it, and we want to see which one takes more time to simulate, and etc. So today I'll be demo on how we use this create 2D design function. So if you use this create 2D design, there are 2 options of the geometry mode. You can see here. The first one is if we have a design that is symmetry on the plane, such as this motor here. You can see the motor is symmetry at the XY plane. So if you use this mode, you can simulate it and in a 2D, it will convert it in a 2D, and you just say what's the height of the design here, like this. And if we use the second one, the mode, which is about Z. About Z is if we have a design that is symmetry sweep around axis. Like for example, if we have a design that is symmetry around the Z axis here, so you can use this mode, the about Z mode. So next slide. So in this simulation, for the geometry creation, we are using the create 2D design function, and then we will assign the current excitation at the coil. We assign the force at the brake plate, and we assign the boundary condition of the simulation. So this is previously designed from part one, the electromagnetic brake, and these are all the specification. So after this, we'll be see on how we convert this 3D design into a 2D model. So next, on analysis setup, we are going to, like I said, same simulation like part one. We are using the parametric analysis to show the gap, to see the field at different gap, at a different gap. Like this one, all there are nine, but there are nine length of a gap here that we want to simulate. Okay. Next, for the result, we are going to plot the force versus gap graph. You can see here, and these are the force versus gap graph on the left side, and we want to plot the magnetic field for different gap length. So on the right side is the result for the magnetic field. So after we simulate this, we will compare it side by side like this on how the result for the magnetic field and also the part of the graph. Like this one, these are all the simulated result. You can see not much of a difference. So before I explain this result, let me do the demo on how we convert the 3D model to a 2D design. So first of all, I'll be opening the Ansys Electronic Desktop, and we'll be using Ansys Maxwell. Okay, so these are our previous demonstration from part one, the electromagnetic brakes. You can see the 3D design. So now I'm going to show you how we create a 2D design from this design, from this 3D design. So simply just click on the project, right click it, and we just use this create 3D design, and we want it to be YZ section plane. And we can see this design is symmetry around Z axis. So we using the second mode, the about Z mode. And then we click OK. So now you can see 2D Maxwell 2D, Maxwell 2D design is created. Now first we want to remove the region, and we want to move half of this design, because we want only the right side, the right part of this design, because we want to sweep it 360 degree, right? So we don't need another this left part. So how to remove this? We simply just we select this all. We right click, edit, Boolean, and we use separate bodies. So all these bodies are separated now. We click, we select all this left part here, and we simply delete it. Now we have the model, the 2D model. What we're going to do is we create a region for this. So we simply create a rectangle here, and we want to, yeah, I think this is about right. and we click OK. So now we are creating the region of the simulation. I want to change the transparency to 0.9 so that we can see it clearly, the design of the electromagnetic brake clearly. So what we're going to do now is we want to create an excitation in the coil. So we just click the coil, right click it, and assign excitation, and we just click this current. And the value is M times number of turns, and click OK. So next we want to assign the force on the brake plate. So we click on this brake plate, right click, assign parameter, and we click on force. So this is the parameter that going to be simulated. So we want to see the force of the brake. This is the gap, right? So we want to assign the parameter of force first, and then we click OK. Now you can see at the left side of the tree, you can see the current. Excuse me. This is the 3D. Okay. Wait. Oh, so okay, this is a 2D design. Okay. So we can see this excitation, the current, the coil here, and the parameter here, the force, and the brake plate. Now we want to assign the boundaries. So we want to only click on the outer side of uh, region, which is these three lines. Because why we didn't click on this line, because this is at the middle of the brake plate. Because you can, if you can imagine, there's supposed to be a two side, right? The left side and the right side. So we didn't click on the middle here because this is at the middle of the brake plate. So you just imagine that this is a box, a big box here. So we only click on the outer side of the box. So we assign the boundaries. We're using balloon, assign boundary, balloon, and click OK. Now we already create the geometry of the 2D design. Now we assigned the solution setup. We just click add solution setup and click OK. We just use the normal analysis, and now we add the parametric analysis. We add. So we want the gap to be changed to this way. So we want to start at 2 millimeter. Then we want to start at wait, let me check what's the let me check the slide back what we are going to sweep. So it's between 0.2 until 1 millimeter. So we start at 0.2, we stop at 1 with a 0.1 step. Okay, so firstly, we start at 0.2, we stop at 1 with the step of 0.1. So, and then we click this back button here and we click OK. So you can see These are all the length of gaps that are we going to strip. Next, we want to save the fill and mesh for different gaps, and we click OK. Now we go to simulation here, and then we validate. And if all are green checks here, this means that we are good to simulate. And now we just right click on this parametric and we click on analyze. So if you see at this progress bar, you can see it's solving all the parametric. So I think it's around not longer than a minute for this simulation to be completed. So we already solved it. Okay, now it is see parametric analysis is done. So it just take a second to simulate this. And now what we want to see is the result, right? So for the result, we want to right click on the result, click on this rectangular plot, parameter force, and we want this force C, and we want the magnitude, and we click on new report. Now we can see the force versus gap result. Okay, we close this. And we want to see the field, magnetic field of the brake plate. So we simply click all. We right click on this field overlays, field B, and we click done. So basically, these are the magnetic field of the brake plate, and we want to see the animation. Just right click this and click on animate, and we want to see in every gap of the field. Click OK. Now we can see the difference between the gap, all the magnetic field between all the gaps here. So we want to observe this as well. And now we want to compare between the 2D design and the 3D design. So we rename this to demo 2D. Okay. So we want to compare it between the 3D and the 2D. We save this first. Okay. We want to see this part right against the side by side with the 3D plot. So like I already compared it on this here in this design. So I already copy the 2D here, the 2D part here. So this is a pre-simulated result. So these are all what we're going to get if we copy the data into this 3D plot. So you can see it is here imported. The green one is the 2D result, and the red one is the 3D result of gap versus the force. So it's a very minor difference. So what we the difference between these two results can be distinguished because of the what we call the meshing probably because of both one is a 3D mesh and one is a 2D mesh. So maybe the slight difference between the meshing that will produce a slight different result, but it's almost accurate between these two. So what we can say is it is a very good result here because firstly, what we can see between the 2D and the 3D result. Firstly, if we use a 2D design, it will mesh faster, it will simulate faster, and the result of the 2D design is quite accurate with the quite similar to the 3D design. While if we use a 3D design, it will take much time to compute. It will take longer time to mesh. At the end, it will have the same result between these two. So these are all the findings uh, for this demonstration. What I'm going to tell you. So I think that's it for today's webinar. So I hope you enjoy this webinar. Thank you for joining. And if you have any question, you can unmute your mic or can just put it at the chat box. So I think Zulaika, you may take over the screen for the next phase of this webinar.
Thank you, Mr. Farhan, for this informative webinar. I hope you have been enjoying the presentation so far. I already launched a poll. Please select the appropriate response and click submit. Now it's time to address your question. Feel free to type your question in the chat features, which you will find at the right of your screen. We will do our best to answer as many questions as possible during this session. Does anyone have a question? Silence means no. It seems that we might not have any question at the moment, but that's perfectly all right. Sometimes topic can be quite comprehensive and may not lead to immediate goal. All right. Mr. Pai, is there anything else you wanted to cover?
No, I think that's it for today.
Great. Thank you, everyone. We appreciate you being here. We also encourage you to connect us with us on social media to get latest information. That's all. Thank you, everyone. We hope you have learned and enjoyed this presentation. Have a nice day.